All right, part 2 of scientific notation. So I just did multiplication and division with powers of 10. Now I'm going to look at approximating with powers of 10. Okay, and just a reminder, I would recommend you guys do a couple of these problems from each one of these practice assignments before you get into the quiz. So that's why I do this as well. Okay, so Peggy the pig built a house of sticks. The stick house can withstand wind speeds up to 47 kilometers per hour. Choose the best approximation of the highest wind speed that Peggy's stick house can withstand. Choose one answer. So either A or B. Okay. So essentially what it's asking us to do is basically round this and then put it into scientific notation. So 47 is very close to 50, so I would round this to 50 kilometers. Okay, so that's a 50. And then now I'm going to put this into scientific notation. So how do I put this into scientific notation? Well, my first number has to be less than 10 but bigger than 1, and then I would be multiplying it by 10 and then some exponent. It has to be to the power of something. So this would be 5 times 10 to the first power. And how do I get that? Because 5 times 10 is 50. So here's what my answer would be for that one. Okay, now on to the second part of this. Patricia the pig built a very strong house of steel. The steel house can withstand wind speeds up to 4,928 kilometers per hour. Choose the best approximation of the highest wind speed that Patricia's steel house can withstand. Okay, so same sort of thing. We're going to first round and then we're going to put it in scientific notation. So this is very close to 5,000. So I'm going to do a different color here. So it's very close to 5,000. Now I'm going to put this into scientific notation. So if my decimal point starts right here, when I put it into scientific notation, I need it to end up right here. Oops. Okay, so I need it to end up right here. Okay. So that helps me because it's going to tell me what my exponent is. So that number in front is definitely going to be 5, and then times, and of course it'll be 10, but to what power? Well, this is where this little jumping comes in handy. So I'm moving over 1, 2, 3. So that means my exponent would be 3. So 5 times 10 to the third power is very close to what this steel house can withstand. And that is this one right here. Okay, let's look at this last one here. In terms of ability to withstand wind speed, approximately how many times as strong... Oh, 1 second. Okay, let me start that over. In terms of ability to withstand wind speed, approximately how many times as strong is Patricia's steel house as Peggy's stick house? So basically we're taking this right here. This is Patricia's, and we are comparing it to Peggy's stick house. And then this is Peggy's. So that would be 100. And how do I get that? Well, I have 10, and then over here I have 1,000. So it's 100 times more. It can withstand the wind speed 100 times more. All I did was subtract. So like 10 to the third minus 10 to the first, which gives you Am I still in writing mode? Yeah. Which gives you 10 to the second, and then once we do 10 to the second power, that gives us 100. Okay, so that's how I got that right there. Alright, so let's see if I'm right here. Check! Okay, I don't think I'm going to do another one of these. Oh, Harvey Potter is a wizard. I wonder who they are talking about there. I'm going to leave this here. Alright, I'm in the next assignment here. I'm in scientific notation. Okay, so it says express this number in scientific form. So I have this right here, 1.588 times 10 to the negative first power. Okay, so standard form. This is something that you guys do quite a bit in elementary school. Standard form, and all that means is just like a regular number. So if I were to say like, oh, I have $286, how am I going to write that in standard form? This is how you write that, 286. Okay, so that's standard form. It's just regular numbers. So basically, it's just asking us to solve this. And since this right here is -1, that means that this number is going to be getting smaller, and I'm just going to move it, and because it's 10 to the -1 power, I'm just moving this decimal over one spot, and the number is going to get smaller. If this was a positive, then I would be moving it over to the right, so that way this number could get larger. So my answer would be this right here. And that's because my decimal started here, and then it moved over one to the left. And when we're moving to the left, that is negative. Okay, so I'm going to go ahead and write that in there, 0.1588. Check. Okay, next one here. Express this number in scientific notation. So again, something you learned in elementary school. I think this is like a 4th or 5th grade standard. So basically, first we got to start by writing it in standard form. So what does this look like once we write it out? The thousandths is a big indicator that this is decimal. So let me see here. This would it starts with tens and hundreds. So that would be tens, hundreds, thousands. Okay, and then it says write it in scientific notation. So basically I got to get this decimal between the 5 and the 2. Okay, so I'm going to use a little yellow here. So I need this decimal to be 2 spaces over. Okay, so that means that my answer would be 5.2 times 10, and then I know that I moved the decimal over here to the positive side, but it doesn't make sense for me to make this a positive exponent, because then I would continue to move it right. So my exponent would be negative, and it would be -2. And why is it -2? Because I just got to think logically here. If this is -2, then what is this answer going to be? It means that I'm going to move this decimal over 2 spaces. Okay, and then that would give me this answer, or this number that I started with, 52 thousandths, so 0.052. Alright, so now I'm going to just see if I'm correct. So 5.2 times 10 to the -2nd power. Check. Okay, and I think I'm going to leave this here. This next one here, you're going to do the same thing. Your decimal point starts right here. Okay, so right at the end. Alright, it's going to start right there. So how many times do you need to move it over in order to get a number that is less than 10 but bigger than 1? That number that's less than 10 and bigger than 1 is the number that goes in the front. and then times 10 to whatever power. So how many spaces did you move over? All right, so I'm going to leave this here.